You do introductions, actually?
Let me just, you're in 3 seconds, 2 seconds, 1 second, I think we're live. All right. So, good evening, everyone, and welcome to this presentation that Peter was so kind to share with us. Actually, Peter came back. Peter is not new to this community that we have over here. He did another talk several months ago about bigger tests that I would really recommend you also see. It's also on this channel. So what's happening over here, folks? We have this community of ours, which is called the Bucharest Software Craftsmanship Community, but the name is a bit misleading. We are not only Bucharest, we are worldwide. We are 5,000 people of passionate about clean code, unit testing, and getting better in what we do. And I should really rename this somehow because it's getting out of control, larger than I thought it would ever grow. And people start coming forward and sharing stuff. So without further wasting your time, Peter, the floor is yours, please. So
yes, sharing and learning, that is something that I really like. So welcome everybody to this talk. I will talk about test-driven development, but first, of course, I will talk a little bit about me, so you know who is pushing his PowerPoint sheets. Peter Schuler, I live in the Netherlands. I've been a Java developer. For this presentation, I was calculating that I've been coding for 30 years now. I work at Rabobank, a big bank in the Netherlands, and I'm married, have 3 daughters. I have some dogs, and I really care about clean code, TDD, especially testing, code quality, and all the other things that you like to do. And if I look outside my window, I see a nice garden, which needs more attention than I can give it. But that's also something I like to do if I have time. But now, not only about me and why I'm here, but especially why I'm here, why I'm giving this talk, because I really feel that a lot of developers are missing out on some of the really important things, the power of writing your test first. And it's also, I have been coding for a long time, and when I started coding, we didn't have an internet. So I would take my bike, I would ride to the library, I would get a book that said Clipper version 4.0, a big book, and I would browse to it. I would read the functions, I would start coding, and I would write incredibly large files with 40 parameters going in, out. And if I had something of an error or it didn't work as I thought it would, I had no debugger. I didn't know how to. I had to actually put print lines in my code, and that's when I really learned that if you can't get a good feedback cycle on what you're doing, you're really wasting a lot of time and effort, and you frustrate yourself a lot. So I will now launch a poll for the people on Zoom. And I will, of course, say that I do this all the time. So please fill it in. I do this also I've done this more recently. And what I really see that if I ask people, do you know test-driven development? Most of the people say, yes, I do it. If I do know about it. Look, only 3% says they don't know. But then there's 80% of the people there who just doesn't know or knows TDD but doesn't apply it, and it's missing out on so much of the benefits. And I see that I'm in a very well, the numbers are a little bit better on this page. I'm not sure, Victor, if you can share the results with the crowd, which would I expect of a community of this quality. So you can see it's there, but still we have the same numbers. More people try to do it, but still the same numbers of people who want to do it, but they just don't get everything out of it. So our agenda for today is, I want to first talk a little bit about why we do automated tests. And that might sounds a bit silly, but it's really there. I will talk about what is test-driven development, and looking at the results, some of you might think, yeah, I know, but I will give it a quick glance for everybody there. And I will show you how you can apply it, not only in a kata, we all love katas, but also on some production code, actually Rabobank production code. I will do this live in this stream. And I will explain you also why the test development is so good and why the alternatives of writing your test after the fact is really not efficient. So I want you to start helping yourself and to make sure that you start writing those tests first. And in the end, I'm really curious to learn also from you guys and have a discussion about how can we help people to start doing test-driven development. Because to be honest, I have been on a point in time where I was like, all right, I'm doing this. Nobody else is doing it. It works for me, but I don't know. I can't seem to get people to convinced. And then I met some other people online. Some people were really enthusiastic about it. And they made me again feel that this is something we all should do. This is the next level for us developers to start writing our tests first. I am 100% convinced that it will be a big improvement in our code. So why automated tests? Because we would like to go to production often. And if you don't, you really should. And when you automate your test, what you're actually doing is that you take a piece of requirement and you codify that into a piece of something, computer code that can be automatically checked if those requirements are met. And then when you pass all those tests, you get this nice green check mark, and then you can go to production. And that is really, really powerful. Because the alternative again is manual testing. And manual testing is really, really bad because it's extremely time consuming. It takes a lot of time. I'm sure if you had a little bit of experience in the industry, you have had this period where we say, all right, we're going to release our product. But before we do that, we have the regression test week or 2 weeks or even 3 weeks of regression testing just to make sure you can push your product out of it. And then people would start running test scripts and they would click through your application and, well, very time consuming. And you can only do that during your office hours. I mean, you cannot force people to do this 24 hours a day. They just need to sleep and eat. It's also very brittle because if you're testing manually, then either you need to spend a lot of time and energy into making extremely repeatable test scripts, or you leap the risk of people missing something, not clicking right, not executing the test the way it's supposed to be. And it can really kill people because, well, go figure, you just will die of boredom doing all these tests time and time and time again. It just is very wasteful. So why is it so much better to let computers do this? Well, first of all, a repetitive task that needs to be done time and time again and has to have the same result all the time sounds like something that computers are really good at. They don't have trade union standards. They don't say, no, wait, it's 5 o'clock, time to go home. No, they can do this again and again. They can do this at 11 in the evening if you want to push out a quick critical production patch. They will make sure that every test will be exactly the same, except for soda flares, but they have never bothered me. And again, computers never get bored. They might burn out a CPU or two, but then you just get a new one and no harm done. So with this, you can kind of establishing that manual testing is really bad and you should always try for automated testing. So that makes unit testing so extremely good, because if you write a unit test, you would write it for the right reasons. You write unit tests to make sure that if you make a change, your code keeps working. You write it to make sure that if you make a change, your code is still working and it won't have any side effects. And the core question that the unit test actually answers is, do I trust my code? And with that, you mean, is this code doing what it's supposed to do in production? So with that trust and with the creation of unit tests, you make executable requirements, and they prove you from time and time again that your code does what it's supposed to do. And the big thing about it is that every time you run your Maven clean install or whatever pipeline system you're running, if you're on Java or on C#, on Angular, every time you release, you can run your code again and again and again, and all the tests will fire. So having all these tests there can make your code base much more trustworthy, and also the risk that you're taking by releasing new software fast, it goes away because you can prove to yourself every time you make a change that everything keeps working. So unit tests are really important in that. Well, what does test-driven development look like? If you look for a test-driven development, you can you simply write a test, you make it fail, you write some code to make the test pass, then you can refactor that code and you keep this in a very short cycle. So you make a test, see it fail, you write some code to make it pass, and you go on and on and on. So every time you add a test before you add your production code, and this way you force yourself and you ensure that every requirement that you're coding is actually covered by a test. So again, if you look at it in a smaller detail, you actually say you create a test and you say, oh, a small part of your requirement. You run that test and you see it fail. And this is the thing that is so important and is so valuable. So you have now a failing test. In order to fix that test, you write a small piece of production code. Now you run your test again. It will now turn green, proving to you that this test actually, that the production code changes you made are now fixing the test that failed because they weren't there yet. And then an important part is that you can now refactor if needed. And this is also something that you should not think too lightly about, because if you have a good test suite, you can, in theory, throw away your production code, rewrite it any way you see fit, run your test again, and if they all pass, you're good to go. Just think about the power you have if you have good tests, and you have made them in the right scope. You have given them the correct scope. So what I think is a very crucial point that people miss, or is that you write your test up front. And I think that is the most important part. You test first. You write your test first, because if you do that, you see them fail. And with simply seeing your test fail, you test your tests. And we don't need to test the test, but if you test your test, you get a very strong feeling of this test is correct. It actually proves what I'm doing, because it's very easy to write a green test that actually doesn't test what you're doing. So by writing a test up front, I feel that is the biggest benefit. And that's why I say that test first is so important. And that's the big benefit. And that's what everybody should strive for, to write this test first and see it fail. So some of the very important things that are there with test first and why it improves your quality so much is that it tests your requirements. Before you start coding, you have to think about your requirements. Are they unclear? Are they missing? Do they not make sense to you? Then you know that you can't start coding. That is really helpful in preventing the first errors, misunderstanding. They force you to communicate clearly about the requirements you're going to build. As I said, you test your test, you see them fail. Very powerful feature. It also helps with the design of what you're testing, because, and we'll see that in my demo, the test is actually the first client of your code. So it's already consuming your interface you're making and seeing whether it should fail. Then after all that is done already, you actually get your correctness. So this proves that your production code works. It even does more. It proves also that your test works. So it proves both of them correct. And this makes you really agile. I am not afraid to refactor code that is covered with good tests. And I don't need to write tests then, because I'm just refactoring code. I'm making internal structural changes that should never affect your tests. That's also one of the things that I have a strong opinion about. And as Victor said, I talked about it in the bigger tests are better talk. So demo time, we're going to do some coding. So I'll start with a small kata to give people the feel about what test-driven development is. And I have a test-driven development kata right here. I will make it a little bit bigger. We have a README that says these are actually your requirements. That says, well, I have a bunch of requirements and we coded them all. If I go up here, I would be really embarrassed if it didn't, but this will run and all the tests will turn green. Oh, except for one. Well, I will ignore this one because it will not be part of the demo today. But be sure I will go back and fix this, of course. You have my Boy Scout honor on that. What I wanted to do is look at this game. We have the production code over here. We have a board. I just made a tic-tac-toe for everybody knows this. I expect you have one row, you have 3 rows of 3 fields, and I just made one big string out of them. You can take player X and player O can take fields. They can only take a field once, and every time somebody make a move, we check whether we had a win condition. But this game is played by 2 players. Let's try if we can make an AI for this. So in order to do that, we have here a simple unit test that says, all right, if I start a new game, if I start a new game, the board should be 0, 0, all zeros, because if people make a move, that is important. If the player takes the first field, then let's assume what should the second player do? And well, we say there is no second player, so let's say what should the AI do? So if this player is X, then the AI player should be the O player. So now we can look at this and we can say, all right, what do we expect from the O player? Well, we need to implement an AI, but let's first then, what should be the result? So if the player 1 makes a move, then the AI should also pick a move. So now we have some freedom. We can say, okay, let's say that if the player made a move, then the AI will always try to fill the second row. I'm just making requirement up right now, but this is how, and we make a test for that. All right. All right, of course this doesn't fit, this doesn't pass because, all right, it doesn't work. So let's fix this. And you can do TDD in an extreme form where you say, all right, I will make very small iterations that initially look stupid, but will end up with correct production code. So I can do here, okay, so if player O takes this, I can now say update board. So if he plays something, then the AI will take the first row with, oh, actually, I can just do this. I can internally call this function. And I can just do this. So now if player takes any field, the AI will kick in and it will say, all right, I will take the next field. So let's run the test now and see if it's correct. It's not because I probably made a mistake. Yes, I'm not testing my test actually, because apparently I am, well, interesting, XXX. It's taking the X. Oh wait, so it should be, what should I take? Embarrassing, don't know your own game. Oh no, this one is wrong. It should be like this. So you already see here that
yeah. 0 versus O. It's terrible.
Sorry?
0 versus O.
Yeah, that's a little bit unfortunate, but it was in the requirements actually, X and O, but you do have a fair point. But you already saw that I made a mistake in my test, and my test actually told me that, hey, your test is wrong. The outcome was correct, my test was wrong. So let's now run these tests and see if I didn't break anything. So we can also go in here and we say run all the tests in this folder, because it's good to run your test suite as often as you can. And oh, everything breaks down now because suddenly I implemented something new. So this means that I need to do something else. So let's say at game and say here public. Well, we have a game. So what does game take? Oh, I can make a private Boolean driven, and it defaults to false. And if I now run all my tests again, oh, it will still won't fail. And then I will say here, if AI driven, then only then do we of course start thinking for the second player. So we run all the tests again. They all pass, except for the one we're actually making, because we forgot something. So we need something in here. All right, so I'll look away now because I'm doing something evil. I'm putting in a flag parameter into this as I just create a constructor, and I say AI driven is true. Now I run all the tests again. Oh, of course, compilation errors, because we also need to have now a simple no args constructor over here. Test again. So you see how you get in a cycle where you make a change, you get feedback, and you fix it, and you go on and on and on, and it now works. Now, all right, now let's do some refactoring because this is really ugly. So let's just rename this to also AI.
It's important also to note that the passing tests are not visible.
Ah, yeah, that's
Yeah.
too bad. Yeah, you're missing on all the fun. You're right. So now if we run everything again, because I made a code change, let's make sure that it works. It works now. And as you can see here, so I could easily, I made, I think already 3 mistakes that were quickly caught by my tests. So this is really a powerful way of developing. But this is, of course, you can say, yeah, but Peter, this is just your own game. This is not production code. In real life, it doesn't work that way. Well, lucky for me. Let's try to find a presentation. I actually have a production issue right here. Some of you might know or not know, I work in a place where we have the calculations for your mortgages. So if you're in the Netherlands, if you want to have a mortgage, we can only loan you so much. That is all regulated by the government to make sure that banks don't loan too much money to people. But as the government also finds it's very important that people can loan a little bit more if they make their house sustainable these days, there is a simple requirement that says if one of these flags is true, and we're just a calculation, we don't never worry about when they should be true or not, then people can loan more. And it's one or the other. So if you get the first one, you don't get the last one. So this is a requirement we have. And well, let's look at some production code and see if we can do that. So in this product, what you should know about this is that this is a kind of complex calculation. And the most important value that we can get out of this is that there is a loan to income percentage that should be below 100. And that means you can buy the house. If it's above 100, we can't give you the loan. All right, I of course prepared the ground a little bit. But as you can see, we have here a sub-calculation where actually we can put in these flags. They're all now false. So the first thing I now need to worry about is, okay, what should I do first? So let's look at requirements again. All right, we have a 0 net energy flag. Well, let's go to the code again. And I will actually close this project because we don't need to be here anymore. And that should actually be mapped to, I don't know, let's take this one. But we should look at it at a functional level. So what should change in the test? Well, luckily there is here another test that already kind of looks like what it's supposed to do. What a coincidence. But so let's think about this a bit. We can see that creation of the input and actually doing the things are already there. So we can put this in here, and then we get a result. All right, what should we do on the result? And of course, I have much more domain knowledge than anybody of you here. Well, assuming. So I know that we have this field over here. that we get a result, and we have a helper function that says, all right, give me for a certain year 0, we're 0 based because we're in a list. All these things you need to know before you can effectively write your unit test, but you also need to know that if you want to effectively write some code. Now,
Wait, just a question here. The year method, that's a test helper method, right?
yes, I can show it to you. It's
Simple thing that just gets the lead from the list. Okay,
yeah,
okay.
it's just because if you scroll up in this class, you see some of them, the methods are really, really big with a lot of asserts, and just writing this year makes it a little bit readable instead of having all this list, get, index, get, because I know the list will always be there. It will always have nine elements or 10 elements. This index 9 will be the latest. So it's a helper method.
Okay.
To get to the place where the result is what I want to see, because we want to check it for every year. Let's see if I can now find my method again. This is one of the drawbacks of having big tests. Let's see. Sustainability. No. Yep. All right. So first of all, this is from the audit test, so I can remove this. We don't worry about the collateral objects in this test. We only want to know if one of those sustainability flags has been set, and we're going to set the 0 net energy flag true. All right, at this point we can run this test and see if it fails, because I expect it to fail because, well, this value shouldn't match it. And I also start questioning myself, why is this such an indirect test? Because I would expect that there is something that says, all right, we have an additional percentage or an additional extra value of that 25,000 euros. So one of the things I can now do, for example, I will debug this single test and see if there is something better in this interface, because this is really bad. I mean, there is no relation between this number and anything I do here, so it doesn't make for a very good test. So I can now, I use the debugger, it might be a bit small, but I can now go into here and see, is there anything that actually makes sense, makes more sense? But I already did this, I know there isn't. So you already see here the value of your feedback. I see that this interface is actually missing some valuable information. And when we ran into this problem, we were like, okay, we don't have a really good fix for that right now, but it's on a backlog. We say, look, this is not a problem only for me. It's also a problem for people who are using this API. They have no idea what that flag should do. And it would be very nice if we should just tell them, look, this means that you can now loan 25,000 euros extra. So you see that you're getting now feedback on your production code that is actually missing something that might be very well useful for the customer, because this value is a calculation based on several things and then divided, but it should be clear how we get this value. It's not. So there's something, an omission in our interface that we now have identified, like we should fix this. Well, because I'm only mapping, I'm most of the time just happy with seeing that we have the expected behavior. So just throw in this, and I run it again. A nice test, right? It should now be 10.08. But actually, my test passes. Actually, I made a mistake because I have to go in here as well. And I have to say here, I have to say, I need to pass on this parameter. Is it input? What is it? Source. Don't have anything better? I have calculation input there. Get is 0 energy flag. And the good thing about my code is that I don't have a database behind this. I can mock everything. I don't mock anything. I just have the actual calculations there. So if I run this test again, it will give me a different number. I just made a test actually that was failing. I knew it was failing and I didn't fix it correctly. And you can also now see the danger of this interface not being correct. Because this interface is just giving me a random percentage, I run the risk of making some major mistakes. And well, if I now run this test, you will actually see that it works. And of course, I can do this for the other two Booleans I need to implement as well. But what I rather would show you is how a good designed interface makes your tests much more readable. So for that, let's see if this is an interesting test for that. It actually is. So one of the things you can have if you buy a house, that you ask your mom or your dad to sign with your house and finance part of your house. And we call it a co-debtor. And here we have a co-debtor that makes a room amount of 1,000 or 100 euros for 12 months. So perhaps the first month he didn't get a raise, he just not enough money, and mommy or daddy or some rich relative said, don't worry, I will give you some of the money so you can now buy your house. And now you see that we have a much nicer interface because we actually have 3 fields that now respond to this. We have, for example, a year income over here. That is 12,700. And that is higher actually than if it would be based on the income because it's 100 less. We also see that the room year amount is 100. And we set it's there for 12 months. So if you scroll down, you will actually see that in the second year, it will go away. So this also shows you that if your interface design is much clearer and the feedback you're getting from your tests, it really helps in clarifying the results and making a test that to me makes sense, to you might be puzzling because of the concepts behind it. But in the end, because of the interface, you can see, all right, we gave him a little bit more room in the amount he could lend for 100 euros. I can see that 100 euros over here. So it makes sense in my mind. So, and this is what I actually do all day. I just make sure that I have a very big test, because if you run this test, you will see that it will actually start quite a lot of classes in order to make sure that I run an entire calculation scenario. So that will be multiple steps of calculations in a row. But it makes it really easy for me to make sure that as long as all these tests are green, I'm happy and I know that my code is at least functionally correct. And if somebody else made a mistake in perhaps the calculation or the requirements were not correct, yeah, then of course we have bugs. We can fix them quite easily because we just need to find the right unit test, change the code, and run them again. So I hope this demonstration made sense to you. If not, then raise a question. Perhaps I can elaborate a little bit more if that's what people want. Otherwise,
there are approximately 10 questions already, but we can do as you like. We could continue with what you had in mind to present, and then at the end we could maybe.
If there are no questions relating to the specific examples or TDD, if we say I want to see something more right now.
There was one from Ochan, wondering whether it's okay or not to have that many asserts in the
No, it's not. Sonar tells me every time I check this code in, it tells me you have too many asserts. And I like, yeah, I don't care, because those asserts are actually necessary in the story I have to tell.
What's the alternative?
Well, the alternative is that, and I think I could give another talk about beautifying your test code, is that, for example, you make some, it complains about the number of asserts. So one of the things you can do with assert that is that you have an assert and then you open a lambda with a subassert. But that's just cheating. You still have those asserts. You just hide them from Sonar. And you should be careful that you need this, because this basically tells me a lot about if I map this correctly. It tells me also that all the fields are actually working. But I also know that if just this number is correct, it means all other numbers are correct, because if one of these numbers is off, this number will not be correct. That's the habit of the calculation I have here. So you will see that that's why I can get away in those other tests to just say, all right, I just have 3 asserts to make sure that this energy saving amount is actually being done correct.
So you have one big test to test the basics.
Yes, to make sure that all my getters and setters have coverage, but also that they are correct, because they still need to be correct. But then if I drill down on the problems, let's see if I can quickly run everything again. Here. You'll see I have a lot of small tests actually that just, well, test a single aspect of the code. So, for example, here we have one where we have, again, another thing that is correction. So we can say, yeah, we know his income is too low, but we give him a positive correction, or we give him a negative correction. And then I just test, well, I still have a lot of asserts because I need to test this over however long it takes to stop, because these corrections, they run for 1 year, this one for 12 months, and this one for 2 years. But I only test those fields that are relevant here. And if I wanted to be extra sure, I could put that percentage test, that loan to income test in here, to make sure that in the end all the numbers are correct. But yeah, I'm also at the point you're going to say, all right, could this not be done better with, for example, Cucumber? So there are a lot of alternatives you can go to. For me, this was the quickest way to get at least those big tests ready. But yeah, I also have made places where you, for example, make specific matchers that match just an entire thing, but it's still.
And you couldn't basically compare the entire output with an expected object by reflection because only some fields you are interested in.
That is something that you could do, but I don't then see the benefit of the test anymore, because then a test don't tell a story anymore. They then just tell you have this and it should be this. It's I also don't like tests where you, for example, have some input and then check if all the input matches all the output. It's not really valuable. I can sit next to my business analyst and can say, look, I have a LTE scenario here and I don't really care about any of the numbers, except if I put in these corrections, this number keeps on getting wrong, for example. And that can help to actually have a discussion about functionality, and not a discussion about, I have field A and I map it to field B, but it doesn't come out as C. It's, yeah, I want my test to be functional, correct, and to be driven by the functional requirements of your code. And it also helps with incrementing, because when we started, we didn't have, I think when I started this project, the first thing we had to do was add these corrections. And then I just started with making a big, I had a small test with a lot of mocks that just tested the mappers. But I said, well, I don't want to do that anymore. So then I started creating a new test here, just for this functionality. I said, I don't want to write this big test where everything is covered. I just want to write a simple test for this one thing. And then there came a new requirement that actually said, well, we need an entirely new structure for this year table. And that's all right. Then I will spend a lot of time writing a few big tests that test all the fields. And when that was done, we started finding that we needed to add more and more small things again. So then I went back to writing smaller tests. For example, the ones with this energy saving facility amount, where I just want to check if we have this energy saving facility amount, will it in the end correctly represent a change in this value of, in this percentage again. And I would have loved if there was another interface here that it could just say, hey, year result, can you tell me how much the correction was? But yeah, it's not there. And we noticed this omission. We talked to our business and said, yes, that's right. That's really annoying, because sometimes it's really plain that it increases, but in this outcome of this particular function, it's not plain, because it ends up being a factor somewhere in a percentage with 1,000 decimals in the end. So yeah, it doesn't tell me a story, and I don't know if it's correct. What I do know, if I increment these fields, this number will change. And for this test, that satisfies me. If this was the actual calculation, I would have some really, well, we actually test our test with cucumber tests that really check the calculation. So this is more an intermediate project that, yeah, orchestrates over multiple calculations. But to go back to the right question, yes, you sometimes end up with a big test with a lot of asserts. That's just the way it is. And you can fake that by having helper methods or spend some time in having auto matchers that do the matching for you. That can work. And in this case, it's like borderline if we need it or not. But you can also go, for example, to Cucumber and then have some tests. But what I find with Cucumber tests is that because you test everything, you need to test the entire scenario. Testing just a single thing is perhaps not that easy. Any more questions on this, or
Perhaps it's better that if you resume the flow. There are
yes,
over a dozen questions for me to bend Zoom afterwards. So finish what you have.
yes. All right. So after this example, so what would you do if you start? Let's assume that you don't want to do test first and you still want to do test last. Then how would you do this? Well, it means you start coding requirements. And then you're either very sure of yourself or you want to see that works. That either means you need to do some debugging or you need to restart you run your program again to match the outcomes. Then you need to start writing a test because let's be honest, nobody is pushing anything to production anymore without a unit test, right? That shouldn't happen. If that happens, then you should leave that place and find another place to work because we all agree that tests are necessary. But if you now find out that your code is not testable, you need to refactor that code. So you go back to, you change your code, and then you have to again check if it works. And you have to do some manual testing. Now at 4, you could write a test. And you hope it actually works, but if it doesn't, you have to start changing your code again. And will you then again go back to manual testing? So as you already can see here, if you just started with a test, you didn't need to do step 2. You didn't need to do step 3. Step 4 was already there. All you had to do was see that test pass. So you save yourself a lot of work. And before I really discovered TDD, I was one of those persons who always messes up with greater than or less than equals. That's always hard for me. With a test, I just write a test, I specify the outcome and run it. When I did still manual testing, I would throw in system outs, or I would indeed use the debugger to understand what's going wrong. But as we see later on, debugging doesn't really help. So the problem is that if the requirement is untestable, you already see that. And then you can either do debugging or manual testing, which is not fun. And then if you have to change your code, you need to go back again. And it's required when testable. The only place where you know that is if you start writing a test. So if you find out that, hey, I actually don't know what code I'm writing, I cannot test this. This is the only moment where this becomes clear. And then I think the most important part is you see it pass. But can you trust a test you did not see fail? How sure are you then that your test is actually correct? So I might be a bit of a purist, but if I have a test that I see pass, I actually go in there, make my production code, break it again and see it fail because I just want to see and want to verify that this test actually proves my point. Because even I sometimes start making production code changes because it's so easy to do and then go back and write a test and like, yeah, I didn't see it fail. So I go back and break it. So the question comes basically down to this. In my opinion, it's very hard. It's not possible to trust a test that you did not see fail. Otherwise, you're just assuming things. And we know what assuming things brings you. So again, can we fix this? You can make small increments and change your test, change your code all the time, so you don't end up having to write a big test. So you can do that. Some things that I do is I manually break your code, as I told you, to see a test fail. That's a very valid thing to do. I know of senior developers who were famously for the fact that they would ask a junior, say, "Oh, so you have unit tests? Okay, so if I change this piece of code, will it work?" Well, we even made it automated these days with mutation testing. But yeah, so we do that even automatically for you. We can use mutation testing to see if a code breaks, but I can guarantee you that it's much less fun to, after the fact, try to find out which requirement you didn't codify than beforehand. And besides, mutation testing is a very expensive process, which actually can kill computers, I think. So it's not something that you want to run all the time. So all these things that you can do, but you should ask yourself, why should you? Because you have an alternative. There's such much better way. There's a place where the pastures are green and unicorns are dancing around, just waiting for you to sing along. So why would you do all these things? So please, people, as the Mandalorian says, test first is the way. So I'm not sure how many of you are into Star Wars and actually watching the Mandalorian. But he's a very cool person. You can see he has a helmet. He hardly speaks. He's like the guy who walks into the room and everybody goes silent. And even better, he has a very cute baby Yoda over there. So he's like the perfect character. And I'm pretty sure, we can ask him later in this presentation, that he will feel that test first is the way. So then, if me and the Mandalorian are telling you this, then why are you not doing test first? And I think that is a thing that is really, I also want to ask you. So if you have any suggestions for this, please tell me. A lot of people say, yeah, but if I write test, it will slow me down. That's something I hear a lot. I don't, I just, yeah, I just want to start on the production code. All right. Then we have one that I don't hardly believe, but I like debugging because, yeah, you can do all those cool things in IntelliJ these days. You can set breakpoints, you can say repeatable breakpoints, you can execute code, and you can do all kinds of things in a debugger. And you're right, it makes you feel like a programmer. But it doesn't make you per se a very good developer if you know everything about your debugger. It just tells me that perhaps you should try harder to understand the code you write. And that is something I find also very. The other one, I find it hard to make tests before I write code, is a very interesting one. And that's something that's very common. And I get back a lot from people. So I'm really curious to hear your thoughts on that one as well. And then there are always people who have experience with a lot of mocking tests. So the mockist approach, where everything is mock, 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 mock. And if you want to change the internal structure of a class or you have a functional change, your tests don't fail on functional requirements, but they fail because the structure of your code changes. And that is why I feel that bigger tests are better. But it is a valid reason. If you have a lot of these tests, I actually started deleting those tests in the project I just showed you. I didn't refactor them anymore. I just deleted all of them and made sure that my bigger tests would cover all the requirements. And it felt really good, I can tell you. To throw out all those user tests that just mock a mapper. Like, why? So the funny thing about slowing them down is that you really should change your thinking. If you're in a modern environment, you need tests to pass the coverage requirements. They should be there. And I know coverage is not the best metric to tell you what the quality of your test is, but it does tell you whether tests are there or not. Or at least if there are unit tests that touch your code or not. So if you have to make them anyway, they will not slow you down. You can even speed up time by just writing them up front and make use of them. I just showed you, you just don't need to do a whole lot of things. And manual testing is just very wasteful. And it's also something that I was working on this presentation and then just Uncle Bob tweeted this. And it's Uncle Bob, so I had to put it in here. He says, just as I tell you, that if you will write tests afterwards, you will only go slower because you first need to think about your production change and then how that would impact your test. And by doing it first, you already think about the problem and you have your tests. So there. Well, the problem is with debugging, I really see is that I use it. You saw me using it. Sometimes it's just a very easy way to get some insight into your code, but it also means that you don't understand your code at that moment. Because not understanding things is just very bad. It's when I start debugging, it's most of the time when I'm really frustrated. When I started working on this code base, there were so many visitors in there that I just kept track of where I had to debug in order to find where the final mapping was taking place. Well, that's really bad if you have to do that. But it also means that that's when I debug. And if you want to use debug, which is very value valid, because as I said, I always mess up things as much as I don't understand why my test is failing. But if I have a unit test, I can at least narrow down the scope to the very thing I want to test. So that means if I go there F5, 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 next line, and I hit it one time too many, I don't need to go back to Postman, send the entire request, or go back to my front end, replay the entire thing. No, I have a unit test there that can just rerun and then it's fine. So I really find that if I have good tests and I have good requirements, I hardly ever need the debugger. So debugging, fine, but understand that if you use the debugger, it actually means you don't understand your code right away. Well, and then there are a lot of people that say, I find it very hard to write tests before I write code. And in my opinion, that only holds really true if you get requirements like this, like open client controller, go to line 15, insert an increment to the client nose picker, and then add, make sure you return the content in this function. So if you get very strict instructions on your code, otherwise this doesn't hold true. You need to understand your code to make those changes. So why not translate that into tests? And just yesterday was a very good presentation about TDD anti-patterns. And somebody said one of the anti-patterns, and I don't really agree with the term anti-patterns per se, but he said you can make a test list. And with test lists, you just sit down and write down a little bit about what kind of changes you need. So in this case, I would say, well, we need to do something about nose picking. So how can we do that? What in the test could reflect the nose picking? And if you go back in my presentation, let's forward. All those animations, a test list. So you write a little bit down and you say, all right, what should happen? You can translate this to an input and say, all right, if I put in this value, then what should happen? So making a small test list, like you saw also in the kata, can really help you to break down. If you struggle with breaking down a problem into the functional requirements or the functional requirements into test input, that can help you to come up with good ideas what you should change first. And if you know what you should change first, then you know what you can test. So I would really challenge you, if you think this way, challenge yourself. Really try to think, okay, I know I have to go there and change this, but what does this change mean to the input of my function? What does it mean to the way that you actually, your clients interact with your code? Because your code is not about the code, it's about what the output. That's the only thing that really matters in the end, the output of your code. And that is something that you can test. And if you can make it into code, you can actually make it into tests. I strongly believe that, and I know that you can. So I would ask you all, next time you think, let's write some production code, go back and say, okay, but how should this impact my tests? All right, then again, I have a lot of very bad experience with tests. They don't work for me. I just write them for the coverage. And most of the time, when you keep asking why that is, it comes down to the fact that you have a lot of mock tests. So they have tests that fail on the structure of your code and not on the behavior of your tests, of the behavior of your actually of your production behavior, your business requirements. And this is, I feel that this overzealous mocking is very dangerous. It's a very big warning sign. Well, and luckily there's just a guy that can help you with this. I have a presentation on this, which explains the dangers and also what you can do to fix it. And as I showed you, by making big tests that cover a lot of code, and I don't care if they then suddenly become integration tests, then yeah, you make your life much easier. You have less tests, they have a bigger scope, less to maintain, and you only change them if business requirements change. So with this, I want to explain, I hope I explained to you that writing your test first has benefits that you cannot get in any other way. It's just not possible. Because when you're writing, you're always missing out how good of a guru you are. If you don't write your test first, you're missing out. And if you don't believe me, let's see what the Mandalorians have to say about this.
This is the way.
This is the way. This is the way.
Well, if that's not convincing you, then please listen to Chuck Norris. He also says test first is the way. So people, from now on, when you work on your code, think about automating testing first, and that means unit testing on when we are working in it. Just make sure you have those automated tests. And I say unit tests, but I also see a lot of people who are making UIs, and you can unit test UIs just fine. But UIs, it might also be important to have some Selenium tests or automated tests. And if you don't do that straight away, if you don't make time for that straight away to have some Selenium tests that just test your flow of your screens, you're going to be in a pain, because then you have to tell your product owner, look, we need an whole sprint to fix this, and we need to put all those IDs in all our clickable things on the screen. So also there, think about your automated testers before you start with your production code. And then write your unit tests up front, see them fail, and then make them pass. And with that, I come to the end of this presentation. I hope you all go out there and be happy test-driven developers. I want to know, I want to open a discussion. I want to share your own experience. There were some questions. And I also have some excellent references to some presentations that were really inspirational for this very talk. I will also share them in the chat and on YouTube, Victor, if you want. And I will look up that the other thing we talked about when there is a good moment.
Right. Now, what do I do with with the 15 questions we have? I think it's the safest if I share the screen and so that everyone can read the questions and maybe we can debate on them and note some stuff. So if you don't mind, I'll share over you. All right. So let's see how this works. All right. So reactive testing. Let's move that a bit lower. One of the common themes in the questions they got in YouTube and in Zoom is integration versus unit tests. So let's start with something more easy first. How long did it take you to truly be max at TDD? So how did
yeah, I think it's not TDD is as you can see is quite simple. It boils down. The steps are really easy. It's like I can explain quite quickly to somebody how you can drive a car. Put the gear in first, hit the gas, go forward. Moving the car is simple, but then driving to traffic and knowing how to behave in traffic, that's something different. That's why you need to get your driver license. But it comes down to experience, because there's no license for TDD, just experience. I think the most important skill that you need is to be comfortable writing unit tests. So know your framework, know JUnit, know SRJ, and also know not to go ham on them. I also see people who go then into SRJ and then they again say any item in a list matches its own matcher. Keep it simple. But that's what a lot of things, if you keep it simple, that's much better. But keep on practicing. Just that's the beauty of unit tests, and that's why I love them so much. They're not production code, they're test code. So if you feel, hey, would I use var args over here? Would this code be better if I had a manual builder? Could I extract this with a manual matcher, or do I need some? Do I come up with some nice domain-specific language to generate my tests, my test data? It's all there. You can do that, and of course, it should be readable because you write tests for other coders, or yes, they are the ones who gonna read it. But it's something you can continuously improve for yourself, and writing a simple test is not that hard, and then going from there and making them bigger. But always think about the interface. Find a nice high-level interface, and it doesn't have to be your controllers. It can be a submodule, it can be a calculation, for example. We also test them very specifically on the outcome. And then we test the scenarios, but in the scenarios, we don't really verify the calculation. We just use the output of the calculation to see if we put in the right things and we match the right things together. So
I would actually add here that you would need to think in terms of responsibilities and roles. The components that you feel, like some things are kind of, they cluster together naturally. Like sending an email, that's a component, whatever that involves templating, I don't care, that's sending an email. So test at the boundaries of the larger scoped components, not super tiny methods. Yes.
Yeah, you could, for example, I think that's a very good observation. I think you can also then go back to something that you see a lot in event sourcing or in domain-driven design. You say you have a bounded context of things that work together, that are the high-level entry points to your code. And those are most of the time good things to write your test against. And that doesn't mean that you have to mock everything that they do. It means it kind of defines the scope of your test. It doesn't mean that you have to mock your database or you have to mock all other things that are outside the bounded context, but that's a different story. But it does make your life a whole lot easier if you see that you don't need to mock everything. And if the real thing just works, use the real thing.
Tough one. How can one start TDD on a legacy project?
Just do it. Yeah, I was once working on I had to make a change to some homemade login code, which was horrible. And it took me like a day or two before I had a unit test. It actually, I'm not sure if I had to use power mock, but I mocked one thing and then I put a stub into another thing, and I had to do a lot of things just to get it to work. But in the end, and I had to use mocking because the things were static, and I even had to do some refactoring to make sure that I had to wrap static calls into a class I could actually mock, for example. So I made the code testable first, and then I started making the changes. And of course, that then requires you to tell your boss, hey boss, I need this change will take a little bit longer because I need to do some time. I also told him, look, this is your security. This is where people log in. This is where the GDPR will slap you if you make a mistake. So he let me go, let me take, 2 weeks is hard. If your task has been 2 weeks or 2 days, but 2 days extra on a task, well, why not? And the good thing is, if you start doing this, as I told you, I made refactorings and start wrapping static calls, which are notoriously hard to mock or to take out, with mockable classes. So I just put a little wrapper around them, and then I could either inject
I would like to discourage people from doing that anymore, to be honest, because now we have in Java at least Mockito inline, which allows very elegantly to mock the static methods with this framework.
Yeah.
Clean.
Yeah, I think I didn't have that time.
Then it was just power mock. Yes.
Yeah. So
Right,
But
right.
it did make the code better because now we had something that also Spring could attach to, because Spring can't attach to static things. So
Yes,
so
true.
you see that this pays off. And the next time we had a change there, I could actually quickly go in there and change code because I already had a test. So that investment in the beginning into this code was really helpful in the long run. So even there, the philosophy is if you test first, you will reap benefits later on. Because when I had to make changes later, it really hurt me in the end when they had to delete that code. Because after a year or after 4 years, they decided it might be a better idea to just use OAuth implementation instead of writing your own security related stuff. But it was really like, but this was my first code I pushed into the system, and now you throw away all those.
Exactly,
Yeah,
exactly.
my child, but it was for the better.
So
But
use hardcore tools. Don't be afraid to do. I mean, you need initial refactoring. You need to use dark forces. But then in
and
the end, I like to
yeah,
test on legacy code, like being like interim hooks that give you courage to refactor even more.
yes, and also just start doing it. When I joined that code base and company, they had 200 tests, and when I left, they had over 6,000. So by just starting it, it's like, yeah, how do you clean a big mess? You just start cleaning up little place at a time.
Mhm.
And then
Right.
when you start doing it, other people see the benefits and they will also start doing it. So
Yep.
and the question is not really, can you do TDD on a legacy code base? Yes, you can. The question is, how do you get a healthy unit test environment inside the legacy code base? And that is just by start doing it. Because I think that's the big requirement for doing TDD of any kind of unit testing, is that you make sure that you have that it should be possible to do the tests.
That's a very, very, very nice answer. From Sorin, would you recommend TDD for beginner coders? People that start coding with some language that have no prior coding experience. And that comes in the same sense as someone from YouTube asking this same question. Should I do that? Or, I mean, like, we actually learned to code without testing. So what do you think about
I
that?
think you cannot write tests if you cannot code. But I think you start really early on, make people aware that you need unit testing, because it's again like driving a car. I can quickly learn people how to write statements, but what I really should teach them is not how an if statement works, but how they can group if statement together in a class that makes sense and is maintainable, is understandable. So I'm really strong for teaching people skills like clean coding, up front. And of course, it's sometimes good that you make a little mess, so you start appreciating it.
Yeah, you can't appreciate clean code until you've been through some terrible years of legacy, in my opinion.
Yeah, but let's hope that if we start teaching the young people early, that they will never make a mess again. So of course will not happen, because we will always make messes.
I'd like to
But
twist this idea a bit. What really matters is not writing the if, but writing code and understanding the requirement.
exactly, yeah. And yeah, I have been a teacher also for technical university, so I know that some of us can code better than I can, but also people who have never coded in their life, they just like playing video games. And all of these people have to learn. So in the first years of just teaching people how to program, you have so many different levels. You need to have a base level, like, look, this is a database query. And but you should start teaching them also that, look, we have certain rules we apply,
Nice.
and testing should be part of it.
So try to get in that feeling, in that attitude of testing everything you write, because that's how production, that's how your life should look like. Can't escape that. And if you end up in a company that doesn't write tests, then you are not in a good company.
Yeah, there was a quote yesterday in this presentation as well. It said something. Somebody quoted and said, "If you can't change your company, change your company." Something like that. I think Beck said that or something. Yeah,
If you
made me
can
laugh.
change your company, change the company.
Exactly.
Excellent. Change the company. Excellent. Good.
But that's not always something you can do. So that's
That's
sometimes you're just between a rock and a hard place, and you have to do that.
Do you limit TDD to only domain model? or most of the core logic? Or do you try to use TDD everywhere you can? And I mean by that integration layer, for example, integration repo layer.
I try to do it everywhere I can in the sense that I showed you the test and they were on the core level. We also have API. We also have API mapper. So we map our core model, but then again back to JSON. And sometimes I feel like doing double work, but it has its benefits, so we keep doing it. Also, we don't want to have JSON annotations in our core. So I also do their TDD. And yes, I do like to see, we also have real integration tests in the sense that we start up our Spring Boot application, we load the JSON request from the disk, we send it in, and we check the response, and we match every field if they are the same. So
everywhere you can.
no, that's not even Spring Boot test. I think we really go to port 6080 or some random port, and we really check the entire flow, and we have wire mocking there to make sure that our external dependencies are being wire mocked. But personally, I also like to see those tests fail. So if I have those tests, I first run them with my change, and that's a big validation because I made some change, for example, and then I'm already thinking about, okay, which test should actually fail? Because and then I run the test and I see a bunch of them fail, and I go in there and see, okay, why are these tests failing? Oh, and oh, they're failing because we changed the calculation of the market value, and it's now 1% extra. So.
By the way, about the presentation, you were extremely brave to show production. I mean, like, how to put it, that kind of complexity. The stuff you have in there largely exceeds the stuff I normally see in components. I mean, like, that kind of complexity you had in there.
Yeah, I'm not sure. Yeah, I think perhaps then, yeah. Well, I dare you all to be brave so we can learn from each other. I think that should really be beneficial for everybody.
This is a line I've heard several times. As I see, TDD requires very clear requirements up front. Is TDD feasible or worth it when developing features incrementally in an exploratory manner in a company, top company that changes mind and that they reorient the business and they've changed basically when the business changes their mind?
Well, I think it will be feasible. I think you cannot produce any code without clear requirements. Especially if you don't have any clear requirements, it might be a very good idea to have some unit tests, because you write a piece of code and it's supposed to work. And if it's not production code, yeah, you got me there. If it's just some throwaway code, why would you test it? Then again, I have had production issues where a UIer called me in the evening and said, hey, Peter, I want to have some prototyping here. I just want to fling something together. I want to have the first two letters of this user and last name together and see if that makes a nice avatar. All right, fine. I said, all right, but I just hackety-hacked this in here with some GSPs. And when I committed it, I put in a little message that said, this code should never go to production.
Exactly this. Thank you. So help
And
us.
you can guess what happened. 4 weeks later, we had a production issue that users who didn't have a last name would get null pointer exceptions. Because, no.
Right, clear required for required anyway. Good, excellent. So that's a good answer. So if it's a throwaway code, just don't mind testing that much.
But more than, and I think if you do a POC or prototype, you should also think about testability. So it's really, if you ask ChatGPT to generate some solution for you, yeah, and run it. But if that's,
yes, good.
I feel that testing is so important that you should. I think that's what happens. The people say, "Oh, okay, we can do it like this." And it's like, let's build on this because we need this feature tomorrow. And then where are your tests?
Yeah. Right. Let's see. From Swagato, how to test edges, like database, like integration. I told you this would come up. Integration files in the SDK that makes. Or do you want to test the SDK? I mean, I know you want to test the way you use the SDK, the way you configure it, and the way it makes the network code. I understand that they can be test doubled, like mock bean or something like mock or faked, mock fake. What I'm confused now is on how to do them test first. How do you play TDD plus integration points?
Well, I think for databases, it will be very good and beneficial to think upfront what you want to do. There are a lot of options. You can indeed use a test double. You have in-memory database in Spring makes it really easy. it also immediately touches the point that you want your unit test to be stateful, or stateless actually, but the database is stateful. So you might end up already thinking, oh wait, yeah, but I need some kind of test script that populates the database and grows with my test set. You want to think, okay, but wait, I can't test the delete if I didn't do an insert. So I need to use those. I think JUnit has a order test where you can actually say first run in test, then. So you already need to think about that. And I think databases are really covered. Files in that order are a little bit harder, but it's files, for example, are extremely easy to mock if you use a binary stream, for example. I had a lot of places where I had to write to PDFs. I just wrote in, I just made the code testable, so I could, instead of a file stream, I could use a byte output stream, and then I could just recreate, take the PDF again, take the bytes, make a PDF out of it in memory, and look for things that I could test. But it's harder to test. These are indeed edges that are hard to test. But what you can do there, for example, is that you make your code in such a way that what's important for your test, the business things, are testable. So, for example, don't put in your PDF all kind of JavaScript that goes to your domain and concatenates fields and finds the right logic. No, make a very specific output object that has all these fields, and then you have somewhere a byte stream writer that takes that object, matches it with your PDF, but keep it simple. Put all the business logic outside the logic that makes your PDF. I'm not sure if I explain this correctly.
Separate presentation basically from business logic.
Yeah, exactly. That's
output relevant for business should be in an object. That's called the split phase refactoring, right? If you want to use fancy words. Basically, you introduce a new object that just carries the data to the PDF, and you test the object, not the PDF. How would you test
exactly? And then you have some simple tests that test, all right, if I put in a name, will the name show up in a document? So you make some simple tests. But yeah, then again, that might be something that you, and this might be something that ends up as really important. As PDFs is your core business, it might have something that you say, all right, before we release, we have a manual test where we check if these PDFs are correctly signed, and if they don't, tell people that they will die tomorrow. Well, actually, they're fine, because it also depends on how important the information is in this PDF.
We usually, DDD, is it usually associated with unit tests? How about integration tests? If you want to write both unit and integration tests, do you write two tests in the same time? The pyramid.
The pyramid versus the honeycomb is also something you could look up. I was taught by Mauricio Amish that tests should be fast, and if a test is fast, it's a good unit test. And the entire discussion about integration test is not really that important in that sense.
That should be fun. Should be fast.
Yes, you have fast tests and slow tests. And I say that unit tests are fast tests, and integration tests, they take a little bit more time, a little more effort. You don't run them all the time.
That's debatable, because if you super hardcore tune the Spring Boot test, that could actually run pretty fast. In parallel.
Yeah, but I don't see them as integration tests. I see an integration test where you indeed fire up your entire application, go to port 7080 and start firing JSON at it. That's in my mind an integration test. So if you have like a test suite that requires the database to be in a certain state, and then have a certain script, for example, if order starts to be important, that should, and then not,
Test control is a unit test because it is reproducible. It is isolated, isolated and reproducible.
But then if you would mix that with, for example, a Selenium scenario that clicks through a certain thing, make change to the database, and then validates again if the database where, that's where I would say integration test.
All right.
Also, if you start making network calls outside of your control, so you start calling real services or real test services that other people provide, that feels to me like, so if multiple components of your system need to be in sync for the test to succeed,
that's an integration test, yes.
Then I think that you start, then I would call it integration. But again, I had this bigger test or better presentation just last month. And then again, somebody said, but if you call two classes into one unit test, it's an integration test.
Yeah,
And that's
names don't matter.
no
It
more.
matters how you use the names, what you do with them. Why do we classify tests? What's the reason? Maybe we want to have more attention for those that are honest and always failing for the right reasons and not just flaky tests like these. And I would like to classify this as honest tests versus flaky tests. A flaky test can fail for external reasons like sleeps, delays, external state that is not in sync, as you said. But the others that you should have trust in is those that, and ideally those should be fast.
Yeah, I found it a very refreshing take to have fast tests and slow tests.
Yeah, it's a nice point to put it. Yeah. So when doing DDD, do most people keep the DDD test on a unit test level, or is it also common? I think that was already covered. The bigger test is better. Any best practice to tag or document unit tests specifically written for production defects? What stops you from inventing your own annotation, right?
Yeah, or put in the ticket number.
In the commit, many companies do that. Like
No, but also in the name of your function. Yeah.
Right. Actually, after why not?
But those go still after a while because we have been moving from Jira to Azure and then from Azure to another Azure. So it's not. But it helps and yeah. Each of the ticket number. But with bugs, it's really important you write your test first because bugs are mostly hard to understand. So you need to understand code. I once had a very nasty bug. We were keeping store of how do you call drugs, for pharmacies. So it had to match because if they were missing some opium, they had to explain why. And their stock was just off. So I first found a piece of code. Okay, it's in the reporting. So I went to the reporting. I wrote there was no test. So I wrote a whole bunch of tests to see if it was working. It was actually working. And then I went, okay, so the problem is not here. So that's why it's so important if you have a bug to write those tests. Write a test that proves your point. And in the end, I found that it was on a total different screen where we had two connecting transactions. And of course, we would only update one transaction once people had updates. So if they made a mistake and they corrected it, they would only correct it in one place.
That's a very hard to test one.
Yeah.
Are there cases when TDD isn't recommended? Or where and how it should not be used?
It should just feel good for you.
Not.
And I would, for example, if you're just setting up your application and you want to know if you can call the database or not, well, then perhaps TDD is not the first thing to do.
I think we covered a bit about that.
Yeah.
Typing or stuff that is throwaway code or stuff like that.
Yeah. If you are calling an external service for the first time, I do write it in unit test actually. I do write the unit test first. Yeah, so actually I do write unit test first because I always like to have a little bit of code I can just call the external service without any hassle. And I disable that unit test most of the time because I don't want to run it on pipeline. But if I have a problem, I want to have a small test. I can just remove the disabled, hit the button and actually call the production service. And then debug if I have to, or dump the output or so.
I don't know how to answer this one though. I believe
I don't know.
The question is how can I see?
Is there a tool to display all branches starting from rest endpoint? I don't think you want. Why would you want this?
What path could you ever take from when you enter a REST endpoint? I don't think there is such a tool because it depends on the runtime data, the parameters that you call that endpoint with.
Yeah, I think you should ask yourself what you want to achieve, and then ask the question what you want to achieve with this.
What are you
can have a discussion.
It's too abstract question, really. And reactive testing, which is not really to be answered now. How does testing and TDDing look like if you play reactive?
I don't do any reactive programming except that I use streams. I'm not sure if it qualifies as being a reactive programmer. I don't know.
I saw reactive tests. These are incredibly hard to write. Test step verifier and incredibly horror.
So with reactive, we're thinking about the stuff that is in the Angular event model, right? Something like that, or
no. Webflux, reactor, flux mono.
Okay, I haven't really programmed in them anyway. But yeah. I think if concurrency comes seeping into your tests,
Yes, it will.
then you should stop and really rethink about what you're doing. You
That's-
either should go to a much higher level and look at the entire system, and you say, all right, I put something in, something comes out.
I know the answer for this. For according to be in sync with what you're suggesting over here, test that code as a black box from the REST API. You don't care. I mean, like, test the whole thing. Don't start diving into the actual web flux and trying to do mocks that return flux and mono. Try to test the whole thing from the REST API, with like a mock MVC if you're a Java, or firing a REST call to the API a REST call to a in-memory application. Start it. Whew. Okay, one more link from TDD. This is like how. Okay, thank you. Yes, perfect.
Yeah, and then there was the.
I will put all these notes in the event page afterwards.
Yeah. Oh, let's see.
Now, it's super cool, nice presentation, but I have to run.
I have some more for you still. I promised you the anti-pattern.
Yes. That's what we. Yeah, the anti-patterns. If you can share the link, and I will put it in the event page anyway. If you can look, Peter, I have to run to take my daughter. So, well, I will leave you host. Thank you so much for this. Look, you managed to find it. Thank you.
Yeah.
Right. Good. And I will upload all these notes in the meetup page on
Give me one more thing for you.
All right.
But if you have to run, you have to run, because there are
I kind of have to run.
important things in life, and
Yes. All
you
right.
can't keep ladies waiting. That will
No.
be.
No. I still have 30 seconds. I mean, no. Thank you so much, Peter, again for your time and effort.
It was a pleasure.
It was very cool to see real production struggle. I mean, like, wow, you rarely see that. Thank you.
All right.
All right.
Thank you all. I'll have one more link for you. I will share, and then I will also go to my daughters and have dinner. Bye, Victor.
Okay. Bye, friends. Bye.
Thank you all.
Bye. I say end, I will leave meeting. I finally leave.